Lab 3, Basic Linear Inequalities Review. We have 3 objectives. The first is to solve one-step linear inequalities. The second is to solve two-step linear inequalities. And the third objective is to graph the solution for a linear equality in one variable. So let's go on to our first objective. In order to solve a linear equality, we need to use inverse operations. Remember that the inverse of addition is subtraction, and the inverse of multiplication is division. Just like in an equation, whatever you do to one side of an inequality, you're going to do to the other side. So I can add or subtract any number to both sides of an inequality and the solution set will not change. I can multiply or divide any positive number to both sides of an inequality and the solution set will not change. However, here's the difference between inequalities and equations. In solving them, if I multiply or divide by a negative number on both sides of an inequality sign, the direction of the inequality sign is reversed. Okay, we change the direction of the inequality sign, and that's the key thing to remember in solving inequalities. Let's look at our first inequality here. The first example is t minus 8 is less than 3. So to solve for t, we're going to isolate t on one side of the equation. We're going to need to add 8 to both sides of the equation. If I add 8 to the left, I add 8 to the right. So t is less than 11. Okay, and that is our solution. Solve the inequality 8 plus w is greater than 14. To solve for w, we're going to need to subtract 8 from both sides of the inequality sign. Subtract 8 from the left side, subtract 8 from the right side. We're left with w on the right and 6 on the left, and w is greater than 6 would be your solution. Solve the inequality 3n is less than or equal to 48. Okay, to solve this inequality, we would need to divide both sides by 3. N is by itself on one side, but there's a 3 there. When we solve for a variable, remember that we're solving for 1n, not 3, so we would need to divide both sides by 3. And since we're dividing by a positive number, the direction of that inequality sign stays the same. So 48 over 3 is 16, so n is less than or equal to 16 is our solution. Solve the inequality 18 is greater than or equal to c over 2. We're solving for c, so to solve for c, to have it all by itself, we'll need to multiply both sides by 2. Okay, multiply the right side by 2, multiply the left side by 2. 2 times 18 is 36. And if it makes you feel better, write that as 2 over 1. The 2's cancel, and we have 36 is greater than or equal to c. Now, in general, when we're solving for an inequality, we like to have that inequality on the left-hand side, and we'll see why when we get to our third objective. In graphing inequalities, it's easier to always read it from the variable. So if I read it from the variable, 36 is greater than or equal to c would be c is less than or equal to 36. So these two would be equivalent, but this is the more acceptable way of writing your solution. C is less than or equal to 36. All right, solve the inequality. 11 is less than or equal to 5 plus x. Okay, again, we're solving for x, so we're going to need to subtract 5 from both sides. So I subtract 5 from the right, from the left. So 6 is less than or equal to x, and again, we want to read from the variable. So really, an equivalent way and the best way of writing this would be x is greater than or equal to 6. And that's your solution. All right, and our last example for objective 1, negative 168 is less than or equal to negative 12. So I'm going to have to divide by negative 12. Oh my goodness, I'm dividing by a negative number. And remember what we do. Whenever we multiply or divide by a negative number, this inequality sign is going to change directions, okay? I'm dividing by a negative 12 on both sides. Dividing by a negative 12. And what's going to happen when I do that? Good question. Okay. Well, the direction of that inequality sign is going to change, isn't it? You see that? So on the right-hand side, I'm going to have a positive a, but instead of a less than or equal sign, I'm now going to change that. It's going to be a greater than or equal to sign. And a negative 168 divided by a negative 12 is a positive 14. And again, reading from the variable, that would be equivalent to a is less than or equal to 14, which is my desired solution. On to objective 2, we're going to solve multi-step linear equations. And we're going to use those inverse operations again to get the variable term on one side of the inequality sign. Remember, we do this by adding, subtracting, and we can use the distributive property as well. Okay, we'll be using the distributive property as well to help us isolate that variable on one side of the equal sign. And solving for the variable, we're going to be multiplying or dividing by a number again. And remember, whenever we multiply or divide by a negative number, we need to reverse the direction of that inequality sign. Okay. And with all inequalities, something that we can do, and we're going to start doing it in this objective, is you can check your answer by substituting a number in the solution interval in the original inequality and see if that inequality is indeed true. Okay. Make that. Okay. Now, let's do this one together, and this is a kind of graduated, we have steps here to show you that we're going to be using more than one step, okay, to isolate the variable. First of all, we're going to have to add 7 to both sides. When I add 7 to both sides, what is, we're going to be doing this, add 7 to both sides. So we're going to have 4n is greater than 23. And then step 2, two-step process here, we're going to have to divide both sides by 4, and when I divide both sides by 4, basically divide this side by 4, divide this by 4, and my answer is n is greater than 23/4, and that's, you know, it's an improper fraction, but we can't reduce it any more than that. Okay, so fractions can be part of your solution set, your solution interval. All right, so here we go, multi-step process here. We're going to try to isolate that variable first. The first thing you're going to do is subtract 4 from both sides. Okay, then we have 2x is greater than or equal to 20. Divide both sides by 2. X is greater than or equal to 10, and that would be our final solution. All right. Example 2 of a multi-step process. All the variables are not together on one side. So we're going to have to, first of all, collect the variables on one side. So we could add 7b to both sides of the inequality sign. And that gives us 9b minus 3 is less than 5. And then to further isolate that variable, let's add 3 to both sides. Use opposite operations, remember? And that gives us 9b is less than 5 plus 3 is 8. And then to solve for b, we would need to divide both sides by 9. Remember, we're dividing by a positive number here, and that's okay. So the direction of our inequality sign stays the same. So b is less than 8/9 would be our final solution. Okay, example 3. Isolate the term that has a variable in it, so we're going to have to add 3 to both sides first. All right. So m divided by 3 is less than or equal to negative 3. And to further isolate m, we would need to multiply both sides by 3. Remember, if it makes you feel better, you could write that as 3 over 1. The 3's would cancel. M is less than or equal to negative 9, and that would be your final solution. All right. Number 4 is an example where we're going to have to use that distributive property. Remember, whenever you have a combination of addition and or subtraction with multiplication, that's the distributive property. So we're going to distribute this 4, multiply it to each term inside the parentheses. Okay, that's the distributive property. Okay, so I would distribute the 4. So 4q minus 24 is greater than or equal to 12. I'm going to add 24 to both sides to further isolate that variable. And that gives me 36. Divide both sides by 4. And q then is greater than or equal to 9, which is your final solution. And let me show you another method of doing this that doesn't use the distributive property. If you notice here, it might make it a little bit simpler to solve. Notice that you have 4 times q minus 6 is greater than or equal to 12. Well, 4 divides evenly into 12. So if I looked at this a little differently, what I could do is divide both sides by 4 first. The 4's would cancel, giving me q minus 6 is greater than or equal to 3. Then I would add 6 to both sides, giving me q is greater than or equal to 9. Same solution, so just showing you that as long as you follow the proper rules, there may be more than one way to solve an inequality. All right, the last 2 examples in the second objective. And here's another example. Does -4 divide evenly into -32? Yes, it does. So there would be 2 ways we could solve this too. All right, but let's first start by using the distributive property. Okay, so we would distribute -4 to the 3 and to the n, so we have -12 minus 4n is greater than -32. Isolate the variable, so we're going to have to add 12 to both sides. -4n is greater than -20. Now at this point, remember, whenever we multiply or divide by a negative number, the direction of that inequality sign is going to change. So we're going to be dividing both sides by -4 here to solve for n. So n would be less than 5. We need to change the direction from greater than to less than. So that's my solution, n is less than 5. Now the other way we want to do it, if we saw that I could divide both sides by -4 first, that might be another way of solving it, and it is. But whenever I divide by a negative number, remember, we're going to have to change the direction of that inequality sign. So I could go ahead and divide through by -4, and then I would have 3 plus n on the left, but this inequality sign would need to change to a less than sign, is less than 8. Okay, -32 divided by -4 is 8. So subtracting 3 from both sides, I have n is less than 5. Okay, 2 equivalent answers, the same answers, just different ways of getting to that final answer. Okay, last example, isolate variable. So I need to subtract 7 from both sides of the inequality sign. So I have -7y is less than or equal to -63. And again, at this point, we're going to have to do what? Divide by a negative number. When we divide by -7 on both sides, that next step, this less than or equal sign, is going to change to a greater than or equal sign. So I'm going to have y is greater than or equal to a +9. There you go. Okay, last objective. Graph the solution for a one-variable linear inequality. You can write the solution to an inequality using interval notation. Interval notation helps us understand how to graph the solution for a one-variable inequality on the number line. So n is greater than 6 is inequality notation, and the interval notation is from 6 to infinity. Okay? So if I look on the number line here, I'm graphing from 6 to infinity on the number line. So the interval notation mirrors what I graph on the number line. Okay, so that's what we're looking at. Okay, so if I want to graph the inequality, t is less than 11, I want to look at that interval notation. So what is the interval notation? T is less than 11. If I look at interval notation for that, that would be -infinity up to 11, and I would use open parentheses. I don't include the 11. So from -infinity to 11, what I do on the number line here, and let me choose a different number. Okay, make this a little bit larger. Here's 11, and I'm going to choose everything that's less than 11 on the number line. And I don't include 11. Okay. All right. And going to the next one, w is greater than or equal to 12. All right, let me move this down. So W is greater than or equal to 12. That means that every number that's greater than 12 on the number line would be my solution. So the interval notation, which mirrors the answer on the number line when we graph this solution on the number line, would be 12 to infinity. Okay, so on the number line, let me do this. It's not including 12, so I use an open parentheses, and it's everything above 12. Okay, 12 to infinity. Remember, on the number line, we assume that negative infinity is way over here somewhere, and positive infinity is way over here somewhere. Remember, infinity is a concept, it's not a number, but that's why we have this arrow that it goes on forever and ever and ever in the negative direction, and the arrow goes forever and ever in the positive direction here, and that's infinity. Okay. All right, n is less than or equal to negative 4. Now on the number line, here's negative 4, and let's see, do we include negative 4? Yes, we do, because it says less than or equal to. So let me get my tools here. If we look at the interval notation for this, the solution is everything that is less than or equal to negative 4. So the upper bound is negative 4, so I would have an interval notation. I would go from negative infinity up to negative 4, and I would include negative 4 in my solution. So notice that for negative infinity and for infinity, we always use an open parentheses. We can't include that number even when we have a less than or equal to sign or a greater than or equal to inequality sign, because it's a concept, it's not a number. So we'll always have an open parenthesis with infinity or negative infinity. But if I'm looking at the way that I would graph this on the line now, here's my number line, here's negative 4. Okay, I include negative 4, so I use a bracket here. Okay, and everything that's less than that, less than or equal to that. So on the number line, that would be everything that's less than negative 4. So you just kind of shade it there. Shade it a little darker than, or a little bit thicker than the line there so you can see. So negative infinity is over here somewhere, it's that concept, up to and including negative 4. All right. And last but not least here, we're looking at graphing the inequality negative 1 is less than c. To remember what we said? We always read from the variable. So really, an equivalent way of saying that is c is greater than or equal to negative 1. And this is a desired way for us to look at it, especially when we write it in a different notation and when we graph it. We want to read from the variable. C is greater than or equal to negative 1. If I look at the interval notation of that, negative 1 is included. It's included, and everything above it is included. So I would have negative 1 and everything above it, and it keeps going and going and going, greater than or equal to negative 1. So that would be all the way up to infinity. And since infinity is a concept, we use that open parenthesis there. So negative infinity up to negative 1 up to infinity. So here we go. Let's look at how we would graph that solution on the number line. Here's negative 1. We include negative 1, you want everything above it. So see how we mirror that interval notation? See how the bracket is going the same direction? So we're at negative 1, and it's everything above negative 1. So we would kind of just shade and thicken that line over to the right of negative 1 and have that arrow to indicate that this is going to infinity. All right. And just for a concept check, you should be prepared now to answer your questions on the Lab 3 worksheet. If you have any difficulty, please take the worksheet to the Math Lab along with your specific questions. And the Math Lab locations are listed below here, and they should be on your lab worksheet as well. And good luck to you.